Hello. In today's video, we are doing the master side of this step 3 of the handshake. Basically, we need to send a full resync followed by the replication ID and the master's replication offset. And this should be in response to the psync command that's sent by the slave node. And we just need to send this message back to the slave. After that, actually, we need to do something that's known as a full resynchronization process, which follows after the full resync, and we'll get to it later, but just stick around for it. So let's just go ahead and read the requirement. In this stage, the master receives a psync from the replica. After the replica sends repl_conf twice, it sends a psync with a question mark and a -1. The question mark is the first argument. It's the replication ID of the master. It's question mark because this is the first time the replica is connecting to a master. So it doesn't know its replication ID and it's requesting the replication ID. And we will send it back in response in this format, full resync replication ID. And the second argument is -1 and it stands for the master's replication offset, and it's -1 because again we are connecting to the master for the first time, so we don't know where the master is and we're requesting to know where you are. And we respond back with the replication offset the master is at. And the response looks like this, and it obviously needs to be serialized in the REST serialization protocol. Have they not provided it here? Yeah, it's supposed to be a RESP simple string, so we'll do that, and it's going to be pretty simple. We just need to add another case for psync, and this needs to happen both the TCP servers, the master and the slave, like so. And instead of repl_conf, we'll be calling the psync method here. We don't need to send the client, we're not doing any communication in that method. So let me just copy it and paste it in the slave as well, and now we can generate this method in the command handler. Okay, so the method is created in the command handler. All we need to do is simply respond back with what's required of us, and we can actually check, like right now we are expecting this stage is definitely going to send us a question mark and a -1, but that may not always be the case. If in case my slave is has some data already, then it's going to send the master the offset that it has, and master will respond back with uh, where the master is. So then the difference can be calculated and the further commands can be asked from the master. So and if we know the replication ID, then it will not be a question mark. So we can do some checks. If the replication ID is question mark and the replication offset is -1, then we will respond back with full resync and the replication ID and 0 for replication offset. Now, if you remember in one of the previous stages, we have already generated a replication ID and a replication offset 0 in our Redis config. And so we'll utilize that in this stage. So in here, let me see if we have it. Yeah, we have injected Redis config. So we just need to get the replication ID and the replication offset from the Redis config and send it back to the client. So string replication ID for the master is command of 1 because command of 0 will be psync, and string replication offset master is going to be command of 2, and there's something wrong with the spelling. Replication, what the hell is wrong? Let me paste it there. Yeah, now it's fine. I can check if the replication ID is equal to a question mark. If it is, we also need to check the replication offset of the master if it's equal to 0. Oh, sorry, -1. We'll respond back to the 0. And if that is the case, we just need to respond back with a message full resync followed by the replication ID and the replication offset. And that's stored in my Redis config. So string res equal to this, copy and paste. And instead of replication ID, we have it stored already in my redis config.get master REPL ID and get master REPL offset, and it will be offset. And here is the offset. Oh, the offset is an integer. What's the error here? Math. Oh, it's long. All right. And we deleted the REPL ID from here, so we can concatenate it here. Replication ID, and instead of 0, we need to concatenate the replication offset, and that should be the message that we are sending back to the client. Yeah, that's right. And I can just return it. I think so. Return res, because we are. So what I'm going to return here, I'll just return options not supported yet, because the options we are only supporting right now are question mark and -1. If we get anything else, we are not supporting that yet. So I'll just return that here and return the result back to the client, and my TCP servers are writing to the client as required, and I think that should work fine now. I'll do a git add. I'll do a git commit, and I'll push. Let's see if it builds fine. Is my internet connection slow? The boring part. Seems like my internet connection is slow. Alright, the test's passed. I check the logs, everything is passing. Alright, let's go to the next stage. The next stage is an RDB transfer. Now this is what I was talking about, a full resynchronization. So when a replica first connects to the master, it needs everything, right? It doesn't have anything. It's a fresh instance. So when the replica connects to the master, it sends the p-sync followed by question mark and -1, and that is essentially the replica saying that it doesn't have any data, so and it doesn't have any offset, so it needs the complete data set that the master has. So master acknowledges it by sending a full resync in response, which we sent just now. And after the full resync, the master will then send an RDB file. What is an RDB file? The RDB file is the format in which Redis stores everything. So even though Redis is in memory, it stores the data in file. What that means is the data is returned from in-memory processes and it writes to the RDB file only for backup. So that's the format it takes backup in. And not just an RDB file, it uses an AOF file as well, which is an append only file. And so as write commands come to the master instance, it appends everything to the AOF file, and from the previous RDB file following the next append only logs, we can generate the data from the master. So I'll share a YouTube video with you that'll explain it better than I do. And I think it was by, yeah, I'll look for it in the description. I'll add the link to it. So do watch that video. It's very interesting. It's essentially a guy using Redis as his primary database, and it can be done, but it does require some tweaking, and it's pretty fast. So that's why it's blazingly fast. That's why he's doing it. Anyways, let's get to the topic. So we need to send an RDB file. Now, RDB file is the format it stores the data in, and right now we aren't saving anything to the file system. It's all in memory. So they have provided us an empty RDB file, and its content looks like this. So here's the content of the RDB in base64 format. We can use this string, decode it from the base64 format, and send it to the slave. So that's what they require from us. After the full resync, we also need to send an RDB file. All right. So the master will then accept any valid RDB file that is empty. You don't need to send the data. You don't need to send the exact file above. Any file will work, but we'll just use it. So the file sent is using the following format, the standard RESP serialization. This is similar to bulk string, but without the trailing /r/n. So we will not be able to use our RESP serializer for this. It's a one-time thing, so we'll hard code it in our command handler. And yeah, let's get to it. Let me open the editor. So in my command handler, I already have the full resync. But after my after the master sends a full resync, it also needs to send an RDB file. But my psync command is only sending back a string. So we'll need to fix that. But before that, let me hard code uh, the RDB file that they want us to send. In later stages, we'll convert it to use the in-memory, or sorry, the file system RDB file. We are not writing to the file system right now. We'll do that later. Maybe, if I get to it. I probably will. String, let's call it the empty RDB file. And it looks like, so I'm just copying it from the GitHub that they have provided us. So this is what the string is, and we need to decode it from base64 format and send it back. But as I said, we are only sending back a string, and a simple string won't suffice in this case because we need to send two things back. So we'll create a DTO. Let's call it a response DTO. Now my response DTO, it needs to have two things, a string and let's say a byte array. So the RDB file, I'll convert it into a byte array and put that in my response DTO to distinguish. So let's do public string response equal to null and public byte, let's just call it data equal to null, and I'll generate two constructors for it. Public response DTO, one that takes only this response and one that takes both the parameters response and the byte array, and I'll do this dot data equals to data. Why am I creating two constructors? Because my command handler is sending back strings in other commands. Only in psync, that's the case that we need the response DTO, but in other we are only using a string. So when required, I'll change that, but right now I'll just convert this to a response DTO. And instead of this, we can return a new response DTO of the string. See, it came in use. And here we can return a new response DTO of res, comma, we don't have the RDB file yet. Okay, so we just need to decode it from the base64 format and convert it into this format, right? So the base64 conversion will give us only this, and this length of the file is not actually the length of the string, it's actually the length of the byte array that we will get after we do base64 decoding and then get bytes. So let me show you what I mean. So I have the RDB file. I have the RDB, yeah, empty RDB file. What I'll do is I will decode it into a base64 form from base64. So if you don't know how to do that, neither did I. I googled or ChatGPT. So it's just base64 dot get decoder dot decode, and I can just give it the empty RDB file. Okay, now, so what I meant was, now that it's decoded from base64 format and in byte array format, the length that we need to send back is actually the length RDB file dot length plus this is the length, and this is what I mean. This is what we need to return. All right. So, and this all needs to be converted to byte. So let's call it full resync, and it will be equal to a dollar plus the length and plus a slash r slash n. It's followed by a slash r slash n, and let's, yeah, full resync, and then, oh, the content is already in what byte format, so I need to convert this to bytes as well and then concatenate both these arrays. Let me show you what I mean. Wait, let's call it full resync header, and the byte array header equal to full resync header dot get bytes. All right, and we just need to concatenate this header and the RDB file. So what I'll do is I'll create a helper method for it, public, and it returns a byte array. Let's call it concatenate, and let's call it byte A, byte B, very creative names. And so I'll be honest, I googled how to concatenate these arrays. So bear with me. Byte result will needs to be a new byte array, and its length needs to be equal to a dot length plus b dot length. Now we could use two for loops, but I didn't want to do that, so I just googled. So we can use something called system dot array copy, and what we can do is we can copy from a starting from 0 and ending into, sorry, result ending at a dot length. What am I doing wrong? A0 result. Okay, so it needs the starting index in the result as well. So we are copying from 0th index of A into 0th index of result till A dot length. And similarly, we need to copy from B starting at 0 into result starting at A dot length and ending at B dot length. I hope it makes sense. It's pretty self-explanatory. And we can return the result. Alright, so I just need to concatenate both. Concatenate my header and my RDB file. A better name would be RDB file data. RDB file data. Alright, we're returning what is required of us. But now we need to change our master and slave TCP server methods because they were expecting a string, but now they're supposed to expect a response DTO. So instead, I'll create a new variable res DTO, and in here I'll set result is equals to res DTO dot response. And like I had a string up here, I'll create a byte array, call it data equal to set null, and data equal to res DTO dot data. And let's just abstract this thing, and I'll create a new method client dot send, and I'll send a response and a data. All right, and I'll copy this, generate this method, and paste it over here. And instead of client.output stream, just we need to throw the error, add exception, and if data is not equal to null, we can simply write to the output stream like we are doing right above. Dot write, and we don't even need to do a get bytes. We can just do this. Yeah, it seems right. Do we need to change anything? Yeah, we need to change my master class as well. And we also need to add this. I hope you understand why I need to change in both the classes. I'll do a git add, I'll do a git commit, but the commit message should be... Oh, I forgot to show you the diagram I created. Yeah, so after the master sends a full resync to the replica, it then sends an empty RDB file. That's it. Let's close it, pretty useless. This is the commit message. Yeah, I didn't create it, I used Claude to create it anyways. I'll do a git push. And let's hope my internet is fast enough so that we don't have to wait a long time. Oh yeah, it worked. All right, we can go ahead. So I'll link the video that explains the RDB and AOF file concept much better. If required, I'll create a video of my own and add it to this playlist, and I'll add it before this video. But that guy explains it way better than I do. So I'll just link his video in the description. Please go have a look. And so it worked. Yeah. I'll so the next stage is our replication when we need to propagate the commands down to the slave nodes. So that's the actually interesting bit. And after that we have transactions, and I can't wait to get going. So I'll see you in the next one.